Today we're doing a story. Gather round, children, gather round. Today we're learning the story of Goldilocks and the Three Segments. Once upon a time, there was a little tiny angle named Goldilocks, and she found herself in this strange triangle. And she decided, maybe I should try the segments and see if the segments will fit. So she tried the first segment. It belonged to the Papa something. The Papa Rhombus. Oh, but that segment didn't fit. It was too big. And it made two different triangles, right? This is our angle, side, side, triangle congruence dilemma. Remember how there's no angle, side, side? That's because that Papa segment is too big. And then it tried the baby segment, but the baby segment was too small. It wouldn't make a triangle at all. But then Goldilocks found the third segment, and the third segment was just right. In fact, it was so perfect, it made a 90-degree angle. Hooray! The story's over. Okay, so what's cool about this is that, remember how in the past we couldn't say triangles were congruent because there was no angle side side? Well, there's one little tiny exception to that. That's if we have an angle side side where the first side is the hypotenuse of a right triangle and the second side is a leg of a right triangle. So we have a special name for this one, and that's called HL, and that stands for hypotenuse leg. And the reason why we're calling it hypotenuse leg is because we just need to go over some definitions here. In a right triangle, the side that is opposite the 90-degree angle is called the hypotenuse, and then the two other sides are the legs. The way I always remember that is I like to draw a little person. So here's my right triangle, more or less. And then I say, oh hey, look at this. It's like a guy. Here's his legs, here's his arms, here's his head, and here's his 90-degree crotch. So I remember now that these are legs, legs, and that means the other side has to be the hypotenuse. So keep that in mind when you're thinking about HL, hypotenuse leg triangle congruence theorem. So the hypotenuse leg triangle congruence theorem simply says if the hypotenuse and a leg of a right angle are congruent with the hypotenuse and a leg of another right triangle, then the triangles are congruent. And note here, all the other ones we've had three pieces, right? We've had angle, side, angle, or side, 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 or something like that. This one only has two pieces, so that's kind of weird. What's the third piece?
What are you asking me?
Oh, she miffed it. That's okay.
No, what are you asking me?
What's the third piece to the hypotenuse leg triangle congruence theorem? We have a side, and we have a side.
A right angle.
And a right angle. Yay, she got it. Okay, good job. Good job, good job, good job. Yep. So the right angle is our third piece, right? The third missing piece. Cool. We're going to do some proofs. We're going to use hypotenuse leg in a few different proofs here. So for example, this proof here, it says to use it to prove that the triangles are congruent. Our givens are that angle P and angle R are right angles. So if a right angle, we know that PS is congruent to RQ. Oh look, it's already marked for us. That's handy. And then just by looking at it, you should think, they share a side. Maybe I should think of reflexive property. And at some point in this proof, we may say that SQ is congruent to SQ. I'll put a double mark. Since we have a hypotenuse, we have a leg of two right triangles, we can say they're congruent. Just scribble all that out. In fact, that was already in your book. Okay, see if you can do number 3. Make a pause screen.
Me?
Yeah. Good job.
Read my palm.
Okay, that's enough. Okay, so for this guy, yes, we can conclude that these guys are congruent. Again, think of the reflexive property. WX here this time is congruent to itself. Therefore, we have two triangles that are congruent. We have, I'll just outline them, this blue one and this green one. They're both right triangles. The hypotenuse is congruent because it's a shared side. The leg is congruent because it's marked as congruent. And then, of course, they're right triangles, and that's marked as well. So yeah, we can prove that those are congruent. All right, let's try this one. It's given that angle J and angle L are right angles, so we have two right angles. It says that K is the midpoint of JL and MN. So because K is the midpoint, we should be able to conclude what?
JK and KL are congruent.
JK and KL are congruent, yeah. So I can mark that on here because that's just the definition of midpoint. And then finally, note here, some people would say, oh, look, I can use the vertical angles, but we don't need to at this point because do I have a 90-degree angle?
You do.
Do I have a leg?
Yep.
Do I have a hypotenuse?
Yeah.
I do over here. So not only is JK congruent to KL, but NK is congruent to MK because it said so. It says K is the midpoint of MN over here. So here's my hypotenuse. That's what the proof is getting at here. So I don't need to prove this vertical pair here. We can just use hypotenuse leg triangle congruence theorem for that one. Okay, that's it. That's all I got. Those are our examples. Say goodbye.
Bye.